Today we're going to be talking about Objective 4.2, Control of Metabolic Reactions, Enzymes, Coenzymes, and Cofactors. First, we'll discuss enzymes and their role in cellular function. All cells have basic reactions such as the buildup and breakdown of carbohydrates, lipids, proteins, and nucleic acids. Enzymes control the rate of these metabolic reactions. Most enzymes are globular proteins which initiate specific reactions that lower the activation of energy required to start these reactions. Basically, they require less energy to perform these chemical reactions and they go at an accelerated speed. Enzymes speed up metabolic reactions by a factor of 1,000,000 or more. The word catalyst in definition is a substance that increases the rate of a chemical reaction without itself undergoing any permanent chemical changes, so an enzyme is considered an organic catalyst. Enzymes vary in speed. Some catalyze only a few reactions per second, where others can catalyze hundreds of thousands. Enzymes can work in small amounts because the speed at which they work and the fact that they are not consumed, so they're able to repeatedly function. An enzyme is easy to identify by its name. It will usually end with an ASE. The prefix of an enzyme name is derived from a specific substrate, which means an enzyme that is lipid-splitting is a lipase. The name fits together just like an enzyme would with its substrate. Enzymes are specific and only act on particular molecules. They have specific shapes and is only in search for its perfect fit. Enzymes have what is called an active site. This site temporarily combines with a specific part of its substrate, forming an enzyme-substrate complex. This new product molecule is reversible while the enzyme remains unaltered. The shape of an enzyme is critical to the function. Since they only bind with specific shapes in the active site, some variables can alter an enzyme. Excessive heat, radiation, electricity, certain chemicals, or fluid with extreme pH can alter or also denature an enzyme. Enzymes are rendered inactive at 45 degrees Celsius, and nearly all are denatured at 55 degrees Celsius. Some poisons will also denature enzymes. A metabolic pathway is a series of enzyme-controlled reactions leading to a new product. Each new substrate created is the product of the previous reaction. In a metabolic pathway, a regulatory enzyme sets the rate for the entire sequence of reactions. Regulatory enzymes are limited. These are also called rate-limiting enzymes. In some pathways, the end product inhibits the rate-limiting enzymes. This would be an example of a negative feedback. Now we'll quickly go over coenzymes and cofactors. A cofactor is simply a non-protein substance that combines with an enzyme to activate it. A cofactor helps with a specific activation site to bind substrates. A coenzyme is defined as an organic molecule that acts in the same way as a cofactor. Keep in mind coenzymes are usually vitamins. Now that you understand coenzymes, enzymes, and cofactors, you can see the importance of them. They're essential to the metabolic pathway. A lack of one specific enzyme would result in abundance of these enzyme substrates and a deficiency of its products, which could lead to a fatal imbalance.